there, algebra students. It's Mrs. Tremblay. It's now time for section 6-2. I broke this one up into two sections too. It was just kind of lengthy the other way, as you'll see. This one, just this part has 3 pages to it. It shouldn't take as long as what it seems. So we're going to talk all about properties of exponents, and I've actually kind of pre-taught you some of this information in your skill packet. So a lot of what we do should end up sounding familiar today. Alright, so properties of exponents. The first thing we're going to do is work on simplifying exponential expressions. So you've already worked on simplifying radical expressions, and you learned the criteria for simplest form for that. It's the same thing here. When you have an expression with exponents in it, all of these things have to be true in order for it to be in simplest form. So first off, you're not allowed to have a negative exponent in an expression that's in simplest form. You can't have the same base appear more than once. If you repeatedly multiply the same base or you divide the same base, you're able to simplify those together. You can't have any powers raised to a power. You can't have any products, a multiplication problem raised to a power. And you can't have any quotients raised to a power. This means that you can't have a multiplication problem within the problem, and you can't have a division problem within the problem that are raised to powers. So let's see if we can identify some that are in simplest form here. And you can kind of just use the checklist to guide you. Here I have b over a. There aren't any negative exponents. I don't have 2a's or 2b's. There aren't any powers raised to powers. There aren't any exponents at all. So because that base doesn't repeat, we're good. This one's simplest form. With the next one, I have a to the 4th times b to the 4th. Now I know I have the same exponent, but I don't have the same base. And I'm not taking a times b as a product to the 4th power. I'm not raising a power to a power. This one's good too. Alright, when you look at the next one, I have a to the negative 2nd times b a. First off, there's a negative exponent, and you can see that the base is repeated. That's a no. Here I have x squared times x cubed. I am not allowed to have the same base being multiplied, so that's also a no. Next, I have the quantity of 8b to the 4th power. Pardon me. So this means a times b, right? This is what it looks like when we have products raised to a power. This means that it's not okay. Really, those parentheses in that aren't okay. An expression in simplest form won't contain any parentheses. So this one, no. Here, I have a to the 5th divided by b to the 5th. It said that I can't have quotients raised to a power, but I'm not having the result of this raised to the 5th power. And I don't have the same base, so this one's good. The next one, I have 10a squared over 4 times b. You might think, okay, this fits all those criteria. There aren't negative exponents. I don't have the same base more than once. There aren't powers raised to powers. No products are raised to powers. No quotients are raised to powers. However, hopefully you saw that's 10 fourths. 10 fourths simplifies to 5 halves. So because of that, that's not simplest form. And finally, hope that this will make sense of the quotient not being raised to a power. When you have this in parentheses, it means you have to take s divided by t before you can take it to the 5th power. So this is a quotient raised to the 5th power. Hopefully you can see the difference between these two. This isn't saying the quantity of a divided by b to the 5th power. This is saying a to the 5th power divided by b to the 5th power, which is fine. This one, because of the parentheses, it wants you to divide first and then raise it to the power. That one's not okay. So you should have 3 that were good. Alright, we have already kind of seen this little chart in class. We didn't fill it out formally, so we'll kind of go through to see the patterns for the next set of rules I'm going to show you. Okay, so let's fill out the ones that we know. I know that 2 to the 3rd power, 2 times 2 times 2 is 8. It's not 6. And if you think it's 6, stop saying that. Stop it. 2 squared means 2 times 2, which is 4. And 2 to the 1st power is 2. Okay, so there's a pattern here, right? The exponents are going down by 1 every single time. The base stays the same. And how can I get from 8 to 4 and from 4 to 2? What are you doing? You might be thinking minus 4, but 4 minus 4 isn't 2. So what you're actually doing here is you're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. And here's this 2 to the 0 power. If you recall, I said any number to the 0 power is 1, right? Isn't 2 divided by 2 1? Okay, so now I have 2 to the negative first power. And we might be thinking, I have no idea what that is. Well, look, I'm taking 8 divided by 2, 4 divided by 2. Shouldn't I just take 1 divided by 2? Yes. And I don't want any decimals here. I want exact answers, and if we're working with fractions, I want fractions. So I want all these answers in fraction form. So 1 divided by 2 is a fraction of 1/2. 1/2 divided by 2 is 1/4, and 1/4 divided by 2 is 1/8. So there's a connection we can make between 2 to the positive first power and 2 to the negative first power, and 2 squared and 2 to the negative second power, and 2 cubed and 2 to the negative third power. Aren't those reciprocals? Right? Isn't 1/8 a reciprocal of 8? And 1/4 is a reciprocal of 4, and 1/2 is a reciprocal of 2. So basically what this means is, if you have a number raised to the negative exponent, you can take the reciprocal of that number's solution. So if this was 8 squared, it would be, if this was 2 squared, it would be 4. But 2 to the negative second power is going to be 1/4. So that's what this means in here. So let's put some numbers with this. First of all, I tell you, raising a base to the power of 0, you get 1. So a to the 0 power is 1. It doesn't matter what a is, because any number to the 0 power is 1. So for example, 8 to the 0 power, 1. N to the 0 power, 1. The quantity of negative 4 to the 0 power, 1. And here's where it gets a little different. If I just say negative 4 to the 0 power, and I don't have parentheses around that, this means the opposite of 4 to the 0 power. I don't have parentheses keeping it together. So instead of being 1, this would be a negative 1. So again, we're seeing those parentheses are kind of a big deal. All right, when we're looking at this relationship here, just to put numbers with it, if you were given 3 to the negative second power, I know this is equal to the reciprocal of 3 to the positive second power. So 3 to the negative second power would be 1/9. If I gave you 5 to the negative second power, I know that this is the reciprocal of 1/5 to the positive second power. So my solution would be 1/25. Now this also works in reverse here. If I gave you 1/5 to the negative second power, this is the same as the reciprocal of 5 to the positive second power. So the reciprocal of this, 5 squared, would move on top. So this one would actually be a regular 25. Let's do one more of those. Let's say I gave you 1/3 to the negative second power. I'm going to push it through the car wash we talked about in class. I'm going to push this up, take the reciprocal. So this is the same as the reciprocal of 3 to the positive second power. So 3 squared is 9, 9/1 is 9. So basically, if there's a negative exponent in the numerator spot, push it to the denominator, and it's all cleaned up, it's positive. If you see a negative exponent in the denominator spot, move it up to the numerator, and it becomes positive. It's just that reciprocal relationship, and we saw here, this is why it all works. So let's try some of these, and we're going to use a bunch of different properties to help us simplify a bunch of different expressions. Moving right along. Okay, there are several properties of exponents that are going to help you simplify these expressions. A lot of them we've seen before. I give you the how and the why, and then we can use the shortcut method knowing that how and why. So I've already shared with you that when you are multiplying powers with the same base, all you do is keep that base and add the exponent. And it works because 3 to the 5th power means this, 3 to the 4th power means this, and we have 9 total. So let's try it with these. If I have 3 squared times 3 to the 6th, all you have to do is take 3 to the 2 plus 6. So this would be 3 to the 8th power. And the directions did say write each expression using positive exponents only. So that means I want to leave it in the form of a base and an exponent. So we're done with that one. Okay, here I'm going to bring over the base because they match, and because I'm multiplying them, I can add those exponents. 4 plus -6 is -2. Now, we can't leave it like that, can we? We're not allowed to leave it like that because the rule said it's not in simplest form if we have a negative exponent. So remember, this is the same thing as 1 over 10 to the positive second power. So we rewrite that negative exponent by pushing it to the bottom, cleaning it up, and this ends up being 1 over 100. I don't just want you to type that in and give me some decimal answer. I want the fraction. All right, this last one, I have the same base. I bring over the base. 9 plus negative 9 is 0. X to the 0 power, any number to the 0 power, is 1. That's it. And I know I said to use positive exponents only. 0 is not positive or negative, right? This is really 1 to the first power, but you get to drop the 1. When you have a number raised to the first power, you just kind of leave it alone. It's kind of like when you have a positive 3, we don't write a little plus sign in a 3, we just leave it positive. Okay, time for some quotient powers or the quotient of powers property. Okay, so instead of adding the same base, now we're going to divide the same base. And with this one, all you have to do is subtract the exponents, top minus bottom. This is why it works. 3 to the 5th power means there are 5 3's. 3 cubed means there are 3. They would end up canceling each other out, right? I'd have 2 3's left, which is the same as taking 5 minus 3. So in these, I have negative 5 to the 8th over negative 5 to the 4th. Same base is being divided. All I do is bring over the base, and I subtract the exponent, top minus bottom. So this should really be negative 5 to the 4th power. I have a positive exponent. It's okay. I'm allowed to have a negative base. I just can't have a negative exponent. All right, same thing here, and this is wrapped up in parentheses, so I'm going to make sure I keep it wrapped up in parentheses. That's important. All right, so I have negative 4 as my base, and I'm supposed to take 2 minus 7. So this is negative 4 to the negative 5th power. That's not okay. The exponent's not allowed to be negative. So I have to rewrite this. I'm going to rewrite this as 1 over. Now, when you push it through the car wash, it changes the exponent. You don't change the sign of the number. We didn't change the sign of the number on that chart that we had with all the powers of 2. So I'm going to leave my base alone, and that 5 will now become positive. So that's how I would rewrite this expression. I do want it to stay in fraction form. So right now what we need to do is we need to figure out what negative 4 to the positive 5th power is. All right, let's see here. Or actually, I told you to write each expression using positive exponents only. So you're off the hook right now. You can leave it just like that. It's okay to have that negative base. I'm not raising a power to a power. If you go through that whole checklist, it's all good. All right, last one like this. Same base being divided. I bring over the base and I take top minus bottom. That means this is y to the negative 1st power. That's not allowed, so I'm going to write the reciprocal of it to the positive exponent. Do I need to put a little 1 there? No. I'm just going to leave it as 1 over y. If you need to put the little 1 there as kind of a placeholder to remind yourself, oh yeah, I don't need that, then write it down and erase it after. But this is simplest form. Simplest form does not have the 1 there. All right, next one, power of a power property. So in these kinds of problems, this is where we see a power raised to a power. And we know that 4 to the 3rd power squared is not in simplest form because you can't have a power raised to a power. 4 to the 3rd power squared means 4 to the 3rd times 4 to the 3rd. And 4 to the 3rd means 3 4s and another 3 4s, which give me a total of 6. So instead of writing this big long scheme of things, all you really need to do is multiply the exponents. 3 times 2 is 6. So when we were multiplying the same base, we added the exponent. Do I have 2 bases in this? I don't. We have a single base and a power to a power. That's when you multiply. So let's try it. Here is a power to a power. All I'm going to do is bring over my base. And I take negative 2 times negative 5. And that's a positive 10. This is it. We're done with this one. There's no negative exponents. It's a positive exponent. We're good. In this next one, it's a power to a power, so I'll bring over the base. And 4 times negative 3 is negative 12. This isn't in simplest form yet because I have a negative exponent. So remember, when you have a negative exponent, we take the reciprocal of the same base to the positive exponent. So instead of z to the negative 12, we want to write this as 1 over z to the 12th power. Now it's in simplest form. Last one, power to a power, I bring over the base. Negative 12 times 5 is negative 60. That's not okay, so I write this as the reciprocal of the same base to the positive exponent. So we're done with that. All right, moving on to the final sheet for this lesson. Okay, we have a power of a product property. So I told you before on that front sheet, you weren't allowed to have these parentheses in here. I can't have the product of 3 times d raised to the second power. There's not allowed to be a multiplication problem I have to solve first. So understand that 3 times d squared, I can take 3 squared times d squared. That means the same thing. I do know that 3 squared is 9, and d squared I can't simplify, so I'm going to leave it alone. Okay, so this says try it, simplify. These directions are a little bit, well, no, they're not different. Write your answer using only positive exponents. This is okay. Okay, so if I have negative 1.5y, the quantity of that squared, then I want to take negative 1.5 squared and y squared. I put parentheses around that base because it's negative, and it's necessary that you do that, otherwise it's going to come out wrong. And honestly, this does say simplify. That's the difference of it. So I knew something was different about this. This says simplify and write your answer using only positive exponents. So here's the deal. When you see that in the directions, you can simplify this further. But y squared, I can't get rid of that exponent because we don't know what y is. So if it says simplify and then write the answer using positive exponents, if you look at the directions for the other, it did not say that. It just said to write it using positive exponents only. That means I want you to actually do the number one that you can. So when you take the quantity of negative 1.5 squared, you get 2.25, and we still have times y squared because we don't know what y squared is. Now we're done. We're not raising a product to a power, because in order of operations, you would do y squared first, and then multiply it by 2.25. When you put parentheses around that, you're saying you have to square that entire amount. That's when you'd be having to do the product. Okay, the next one. First off, I have 10y, the quantity of 10y, and it's being raised to the negative third power, right? Okay, this negative 3, it's not allowed. You have a couple options here. What I would recommend that you do, when you see that you have a negative exponent from the start, I would rewrite this expression using a positive exponent. So I would start off by rewriting this as 1 over the quantity of 10y to the positive third power. Just get that taken care of right off the bat. Then break it up. This means 10 to the third power times y to the third power. Now this is what I mean when I say simplify. We can simplify 10 cubed. We know that 10 times 10 times 10 is going to give us 1,000. So I have 1 over 1,000 y cubed. That would be the final answer for that one. And finally, this, do I need to rewrite this as a reciprocal? Because there's a negative right there. Hopefully you're saying, no, Mrs. Tremblay, that's only when the exponent's negative. This one's fine. You're right, it's fine. So I'm going to take negative 2 to the third power times x to the third power. All right, negative 2 times another negative 2 gives me negative 8. X cubed, I can't do anything with that. So that's how that expression should be written. That's our simplest form. All right, the last property we're going to look at is called the power of a quotient property. Let me make sure you can see it on the screen. Yes, you can. All right, to find the power of a quotient, find the power of the numerator and the power of the denominator, and then you divide. So just like when we had the quantity of negative 1.5y squared, it meant negative 1.5 squared and y squared. If you see the quantity of 2 divided by p to the 5th power, this means the 2 is being raised to the 5th power and the p is being raised to the 5th power. And then we can simplify it from there. So if you can just remember with these two, because I know the power of a product and the power of a quotient, it's when you look at it, you might not recognize it as simplest, is it in simplest form or not? Just know that you can't have parentheses. It's not simplest form if your answer contains parentheses. All right, so let's try it with this. I have a positive exponent here. This is great. So this means a to the third power over, and this negative 10 starts off in the parentheses, so I'm going to keep that there because it makes a difference in the end, over negative 10 to the third power. All right, So when we take care of this one, a cubed, I can't do anything with that. But negative 10 cubed, I can. So when you take a negative base and you multiply it 3 times, because it's an odd number, it's going to be negative. I know that 10 to the third power is 1,000, and I know this is going to be negative. Now you could put the negative with the denominator, but most of the time you're going to see it right in the middle instead of with the bottom. Either one would have been fine by me, but that should be the correct answer there. Okay, next one, I have the quantity of negative 4 divided by n raised to the 5th power. This means the numerator to the 5th power and the denominator. Now this negative sign does not mean that both numbers are negative. It means only one of them is. I usually just put it with the top. So I would put the negative with the 4. Remember, you can't put it with both. So this means negative 4 to the 5th power over n to the 5th power, right? Okay, so in looking at this, I want to take the quantity of negative 4 to the 5th power. I don't mind if you use your calculator to help you with this. You just can't type the whole thing in it, because I don't want any decimals. So negative 4, the quantity of negative 4 to the 5th power, it's an odd number, so I know it's going to be negative. It's negative 1,024, and this is going to be over n to the 5th. I can't simplify that any farther, because I don't know what n is. If you wanted to put this negative sign in the middle, that would be fine as well. Alright, next one here. I want to rewrite this. This means that 1 is being raised to the 5th power. And here, okay, this is where it gets a little bit tricky. This means 2 to the 5th power. And I'm taking k squared to the 5th power. I'm hoping that you recognize this as a power to a power. Do you see the difference here? So to simplify this one, 1 to the 5th power is 1. 2 to the 5th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And when you take k squared to the 5th, this is a power to a power, so you multiply, so this should be 1 over 32k to the 10th power. That was a tricky one. All right, the last two that we have left, let me get rid of this. This is a sticky note with your assignment on it. You'll get that in class tomorrow, don't worry. I'm sure you were worried. Okay. This starts off, and there's a negative exponent there. So, when you see a negative exponent, this might seem kind of weird to you. I hope it's not too weird to you. But when you see that we have a negative exponent, we can start off, if you wanted, by flipping around what's in here. Because this means 2x to the negative 5th power and 3 to the negative 5th power, right? Let's just write it like that. I think the other way might be too confusing. So we'll start off like this. I'm going to say 2x to the negative 5th power and 3 to the negative 5th power. Alright, so you learned that if you have a negative exponent, all you do is, if it's in the denominator, you push it up, and if it's in the numerator, you push it down, right? So basically, these are just going to flip. So this is going to become 3 to the positive 5th power over 2x to the positive 5th power. I'm hoping that that makes sense. Okay. Now, we can figure out 3 to the 5th power, right? You just take 3 times 3 times 3 times, yeah, you multiply 5 3s, and you get 243. And now I want to take 2 to the 5th power. Remember, this means 2 to the 5th power and x to the 5th power. Well, 2 to the 5th power is 32. And x to the 5th power is just x to the 5th power. There we have it. Alright, last one. I think maybe I'll show you what you could do with this one right off the bat. I didn't want to do it last time, but let's do it. If you see right off the bat that there's a negative exponent, to make this a positive, all you have to do is flip them. So 6c divided by, the quantity of 6c divided by 7 to the negative 2nd power is the same thing as 7 divided by 6c to the positive 2nd power. So that's another way you can approach this. So this means 7 squared over 6 squared times c squared. 7 squared is 49, 6 squared is 36, and c squared is, we don't know, so we're just going to leave it alone. And then you're done. See you later.